Hello and welcome to another ISS video tutorial. We are going to take a brief look at phasor plots and go over different lifetime comparison tools the phasor plot offers on ISS VistaVision. As we know, the ISS phasor plot in VistaVision is a graphical representation of all raw film data. Each pixel in the image is mapped to the phasor plots at a specific coordinate called the phasor point. This gives us lifetime information of the pixel. The advantages are you do not need to guess the number of exponentials or estimate the lifetime to fit it. The phasor plot lets you visually distinguish and also quantify multi-exponent lifetimes and their fractions. You can go to the ISS website for an in-depth mathematical description of the phasor plot with application examples. The comparison utility in ISS VistaVision makes it easy to see lifetime distribution in film images. There are multiple highlight options to map film image pixels corresponding to different lifetime populations. Using unmixing algorithms, you can false color the film images based on their lifetime fractions, and you can also contrast their intensities. These lifetimes can be single or multi-exponential, so you can thoroughly analyze the entire image. This is a very useful tool to visualize lifetime distribution in your samples. The Lifetime Species Analyzer lets you quantify the different lifetime fractions in the film image. You can analyze and decompose lifetime mixtures into 1, 2, or 3 different lifetime fractions, and each fraction can be single or multi-exponential. So in addition to visualizing the lifetime distribution with false color, we can also use intensity contrast like we saw earlier, and VistaVision also lets you quantify the fraction from each lifetime species. Let us try these utilities out in VistaVision. I have already loaded a sample image in the multi-image phasor analysis window. This is a 2-photon image acquired at 80 MHz. Using the convenient lifetime markers, we can easily tell that this image has several complex lifetime species. Let us add a few cursors at different points on the distribution on the phasor. I'm going to rename the cursors as 1, 2, and 3 and assign them different colors. Let us make the cursor smaller to narrow down on the distribution. If we click on General, we see several useful utilities in the drop-down menu. The Data Comparison utility lets you select and compare up to 3 different lifetimes using false coloring and intensity contrast. Let us select 3-color Enhance option, which lets us compare lifetimes and contrast them using the 3 cursors. Right now, all the cursors are set to 1. If we click Highlight Image, we can visualize the lifetime distribution in the image. We can assign a value of 1 or more to C1, C2, or C3 to see their distribution across the image. You can also select the 3-color intensity option to toggle between intensities of the lifetime distributions. The phasor plot also lets you quantify the lifetime distribution and see the fraction of each lifetime in a complex mix. If we click on 3 species, the phasor space and the cursor tab are auto-populated with 4 cursors. 3 for defining the lifetime species we think are contributing to the mix, and 1 for defining the actual mixture. So we are first going to change the size of the cursor for one of the species and also select different colors for the cursors. Next, we are going to select 3 different lifetime distributions. As we define the 3 lifetimes, they automatically connect to the mixture cursor, which always remains inside the 3 cursor triangle. Let us focus this cursor on the lifetime mix in the image. If we click on species, we can see the calculated fractions from the 3 lifetime species and their contribution to the mix. Clicking on Highlight Image shows how these lifetimes are distributed across the film image. So, the phasor plots are very convenient for data analysis. You can easily compare images and analyze multiple image files in the same group at the same time. Please visit ISS.com to learn more about latest confocal microscopes with single molecule sensitivity.